Hello everyone, my name is Lakshay Bhatia and my team number is Team 100. And today I'm presenting FactoryMind. FactoryMind is a multimodal, autonomous multi-agent manufacturing monitoring system. Manufacturing plants generate massive amount of data every second from cameras, sensors, and machine logs. However, these data sources are usually monitored separately. As a result, quality defects are missed, machine failures are detected too late, and safety violations often go unnoticed until they cause downtime, financial loss, or workspace incidents. FactoryMind solved this problem by combining video analytics, telemetry monitoring, and AI agent into single autonomous decision making system. The process starts with three live data sources. First is a video stream API, continuously capturing footage from factory cameras. Second is a telemetry API, receiving machine health information such as vibration, temperature, RPM, pressure, and other sensors through MQTT or RESTful interface. Third, a log API, which collects machine errors, code, and operational events. These inputs are merged into a unified asynchronous data stream containing synchronous video frames, telemetry reading, and timestamps. Data enters a pre-processing stage. Video frames are analyzed using YOLO, object detection, to identify people, helmet, product, machinery, or relevant object. At the same time, telemetry reading are normalized and prepared for analytics. In this project, I have made use of Qwen2.5-VL 7 billion instruct model and YOLO for object detection, which is running on very powerful AMD ROCm GPU. And I've utilized Microsoft Agent framework to build the orchestration. Hi everyone. Today we are thrilled to present our AI driven factory monitoring solution. In a manufacturing setup, seconds matters. Equipment failure or a single safety violation can lead to massive downtime or severe injuries. To solve this, we have built a real-time intelligent dashboard that acts as a central nervous system for the factory operations. What you see on your screen is a Streamlit driven dashboard that processes live feed directly from factory floor to mimic a real world industrial environment we have built through high throughput fast API backend. So let me show you the fast API backend here, which I have built using fast API. It has some endpoints, an endpoint for the video stream. So basically, I have downloaded a video of a factory floor, which I am continuously passing it through this API. The video looks something like this. Let me show you the video. The video looks something like this. Let me run the video again. Yeah. So this actually mimics the live streaming video from a CCTV footage, which actually I'm feeding in this ingestion API and converting it into a stream of bytes, which is being consumed by our LLM agent in real time. Also, I have a telemetry polling API, which will give you random temperature, vibration, and RPM pressure rating. I'm using random values here to mimic the actual, uh, mimic the sensors, basically, the data coming from the sensors, etc. Going back to the dashboard, at heart of it is heart of the solution are five specialized AI agent working simultaneously. We have a vision agent to detect manufacturing defects, telemetry agent, safety agent, a scene description agent which will look at the CCTV footage, and finally the orchestration. Our AI model analyzed the streaming CCTV footage scene by scene, combining it with the real-time telemetry to make split-second prediction and decision. Going forward, these are few key KPIs which are listed out here. Looking closely at the dashboard, you can see our key APIs here. It tracks the exact number of defects caught, safety violation flagged, most importantly, the hours of downtime saved. For instance, in current live feed, the system is analyzing a worker at the workstation. If you check out the CCTV logs and AI output in granular way, let's have a look. Let's have a look where the person is detected. Okay. At this point, In line number 2 workstation, one male worker wearing a white shirt and a black pant is inspecting a component on the workstation. PPE kit, hard hat, safety vest is worn, which is a good sign. Goggles, but gloves and goggles were missing. Vibration at that time of that equipment was 7.28 millimeter per second, and the temperature was 88.5 degrees. There is no visible hazard near the worker. Risk is low, and also it predicts the accidents. So basically, video stream is looked by the LLM frame by frame, and every frame, along with the telemetry data, it predicts the accident prediction, that what are the chances of having an accident, which is currently shown as 39%. Over 45% would be abnormal, and a flag will be raised, actually. So we have the overview, the temperature vibration in real time. We can have a look along with the vibrations. What are the changes in the vibrations, etc. And safety center basically doing the accident prediction, and the falling risk, which is quite high, as you can see, is over 60%, because eventually in that video, if you see, the person actually falls, which is right. So 65% is the probability that was given from the LLM, uh, analyzing this video. So as you can see, the person eventually falls down. Going back to the dashboard, if we analyze all decision, so there are, on the basis of this data, LLM is free to take decisions because it's autonomous. So if we see the quality defects or safety violation, critical maintenance, let's have a look. So we can see that LLM has taken a decision to shut down the conveyor belt because the temperature has reached greater than 92.2 2 degrees Celsius. So at this timestamp, machine ID line 2 was having high temperature. Therefore, the conveyor was shut for some time. In this project, I have created multiple agents. Here are the list of agents which I have created. The first one is a defect agent. Agents look at the defect analysis using LLM vision capabilities and flag if there is a failure or an overheat issue or an anomaly is detected. So it will flag that. Then KPI tracker. KPI tracker basically is responsible for logging into the CSV file. So I'm collecting all the logs into a CSV file. It can be a database as well. So KPI agent is responsible for logging. Then there is something called telemetry agent. This will look at the live data coming from the API, the stream of data, which includes vibration, temperature, RPM, pressure, and other readings. If vibration goes then 8.0 millimeter per second, it will say it's a failure alert and do the needful. Temperature, similarly, if it's greater than 90, it's an overheat issue. So it will take a decision. Ultimately, the decision would be made by the orchestration agent. So, so orchestration agent basically takes the decision whether, because of the defects, is it a critical maintenance defect, or it's a safety violation, or a quality defect, or is it a normal operation. We can use these agents individually as well. In order to do so, we have something called dev UI. Let me spin up the dev UI. So I'm spinning up dev UI at port 8085. What this dev UI does is it gives us the capability to use these models. As you can see, all the models which I've created are listed out here. For example, if I want to, for the demonstration, I want to use the safety agent. And this is a normal chatbot basically. If I want to use it, I just need to uh, give a video feed or an image. For example, yeah, I have an image copied here. I'll paste it over here and let's see what it does. Yeah, so it analyzes and gives the data in a JSON format, which says it's a safety alert because a person is detected without helmet and safety vest. Falling risk is 35 and accident prediction is 80%, which is quite high. Now for demonstration, I have taken another agent, telemetry agent. I've inputted uh, my input in JSON. So here the temperature is within the limits. So it says decision is normal, nothing to worry about. When I raise the temperature it to 91.5 degrees, it will say it's an overheat. So basically, WI also helps us to visualize the orchestration. For this, let me choose it from factory monitor and run it. So I hit on run, root user, content. I can give a random content here in JSON format. Let me grab something. Suppose here, timestamp, machine ID, vibration, temperature, and then click on run workflow. So first this runs, then telemetry agent, and orchestration decide whether it's normal or a quality defect or a safety violation. In our case, it's normal, and we can see the output as well. This helps us to uh, this shows the telemetry also, the live event and traces we can follow up. For example, we can check the trace, that safety agent, and how many tokens and how much time it took to give the response, and which model is used. In our case, is Qwen2.5-VL 7 billion instruct model, and we can inspect uh, the total number of token usage. The total token usage as per the entire uh, is this input, output, how many. So this tool is used for monitoring and how much tool calls we have done, how many tool calls, which all tool calls we have done, and we can inspect everything from here.